Well, thank you very much, everybody, for joining us. It's great to see you all again. My name is John Dickinson. I am the Chief Commercial Officer at Equal Experts, and welcome to the second in our remote first expert talks. So last week we had a talk by Lindsay Pruer about chaos days, and this week we're continuing the operability theme with Chris Rowe, who is going to talk to us about the Top Gun Guide to DevOps. Now, this talk was originally part of the Leeds Digital Festival, and it still is. So the festival is still going on, but they've had to make it remote first and digital. But we're pleased that's still happening, and this talk is part of that series of talks. The one thing just about how we're going to run the talk, so I'll hand over to Chris in just a second. What we're going to do is, as this is our second expert talks, we are going to try and introduce the Fishbowl concept, which is an approach that we use to engage the audience after the talk in a kind of an around the room discussion. I'll explain more about that after Chris's talk, but that means there won't be a specific Q&A session on the talk afterwards. Instead, if you want to put any questions that you've got about the content, put it in the Q&A bubbles, the little speech bubbles on the bottom right-hand side, as Chris is going through the talk, and then that'll provide inspiration for the Fishbowl or additional things and content for people to talk about in the Fishbowl that we're going to try with afterwards. And we do have a starter topic for that, but I'll reveal it after Chris has given his presentation. So that's it for me until I start facilitating the Fishbowl. In the meantime, Chris, if you want to take it away, that would be great.
Great, thanks, John. Okay, so hello everybody, and welcome to my talk, the Top Gun Guide to DevOps. So my name is Chris Rowe. I've been working with Equal Experts for a year and a half or so now. My background is mostly in software development, although more recently I've broadened my horizons a bit and been doing a lot more infrastructure and DevOps work. My current role, I'm currently working on an API platform for a large public sector client. But in the past, I've worked everywhere from tiny startups to big multinational companies. It's actually not in those areas that the inspiration for this talk came about, though, rather from a hobby I started a few years ago. Before I get to that, I will point out there's something of a deliberate mistake within this presentation. There'll probably be a few non-deliberate ones too, but let's see if anybody picks up on it. Anyway, back to this hobby of mine. In the early 2000s, decided that while sitting in a desk in an air-conditioned office, cutting code was great and all, maybe there was something I could do that was a little more active. So I went and did the most obvious thing going. I went and enlisted at my local territorial army unit. In my case, this was part of the Royal Armoured Corps, so I ended up training as a tank crewman, which I think you'll agree was a bit of a change from the day job. With a few years of experience and a couple of promotions, I got to attend some tactics courses at the Land Warfare Centre, which actually introduced me to some of the concepts we're going to talk about today. Later on as well, I served in the Intelligence Corps, which demonstrated those same principles again, just at a slightly higher and more strategic level. But what I am going to cover actually starts across the pond with the hero of our story here. So let me introduce you to Colonel John Boyd of the United States Air Force. So Colonel Boyd started his career as a combat pilot during the Korean War. On his return, he was actually selected to attend the US Air Force's Elite Fighter Weapons School, which is basically the Top Gun school. He actually did so well, graduating top of his class, he was actually asked to stay on as an instructor afterwards. He was also known as something of a maverick. He actually developed a number of his own theories about air combat. So the dominant thinking at the time was for bigger and more powerful fighter jets. But having looked at the performance during the Vietnam War, Colonel Boyd saw that this wasn't necessarily working out too well for them. So what did he do? Well, rather than just offering an opinion on the matter, he actually did something we'd probably recognise today, and he went data-driven. So he actually enlisted the help of a civilian mathematician, Thomas Christie. With the help of a bunch of computer time, they actually managed to prove mathematically that lighter and more nimble jets would perform better in air combat. And that work actually landed him a job at the Pentagon and responsibility for designing a new generation of planes. But he'd actually later go on to refine these ideas into a more generalized model, and that's what we're going to be interested in here. So that model is known as the OODA Loop, and that stands for Observe, Orient, Decide, Act. So at its simplest, it's basically a four-stage process for decision making. Once you start to explore how it fits together, you can find it applicable in all kinds of areas. So in short, the principle is the more quickly we can move through the various stages of this model, the more nimble we can be in our actions. So if you think about that in military terms for a second, if you're facing an adversary and you're actually able to navigate this loop more quickly than he can, then his decisions are going to be based on a situation that's already changed, which gives you the upper hand. And if you're able to maintain that advantage, your opponent's always going to be reacting and not going to be able to take the initiative. That idea actually had such a profound impact within military circles that the US Marine Corps completely rewrote their doctrine on maneuver warfare to encompass it. And even the plans for the first Gulf War were changed due to Colonel Boyd's input and ideas. And obviously, as you can tell from having me speak about it now, it's even made its way to the British Army. But how is all of that relevant to DevOps teams? Well, we're all familiar with feedback loops, frequently talk about making them shorter and quicker, and we do like incremental optimizations in what we do. So if we're actually able to break this process down into its component parts, maybe we can look at how we'd optimize the different phases. And maybe that would let us respond to issues more swiftly. And ultimately, that should improve the agility of our operations. Anyway, let's dive in and have a look at each stage in turn and see how we might apply the loop. Okay, so generally we start here. This is the observe phase. As the name suggests, this is where we use the tools available to us to sense what's going on in our environment. So maybe literally with our eyes and ears, but it can also be things that we put in place. The telemetry and instrumentation in the applications we build, for example. And I'm sure everybody here can think of 1,000,001 things it's possible to measure in the system we're responsible for. So where do you even begin to start? The short answer to that lies in planning. So by way of an example, let's have a look at how we might approach this in the Army. Okay, so here's our scenario. We've been tasked with defending this Lake District town of Grasmere. We know there are enemy forces and vehicles to the north and west, but there's loads of stuff going on this map. So where do we even begin with that? Well, the first thing to do is figure out what we need to focus on. In this case, I figure that the enemy isn't going to be able to travel over those really steep hills very easily. So we can remove those from the equation. Okay, that makes things a little clearer. Looking now, we can see there are only really two ways the enemy can approach us. Okay, and that's along the roads from the north or the west. Okay, so now we need to consider what might actually happen and how we're going to respond in each case. So let's say the enemy does come in from the north. This is how I might come out to meet them. And likewise from the west. But how about if both happen at once? Well, maybe we figure our goose is cooked in that case and we need to punch out. Sometimes discretion is the better form of valor after all. Okay, so that's three possible scenarios we've quickly mapped out. But in order to be able to respond to what's going on, we do need some advance warning. We don't want the bad guys right on top of us before we react. So how best to do that? Well, if we're able to observe these two boxes, we should be able to figure out which of our scenarios is occurring. So what we've done, we've actually started with a large and complex map, and now we're down to concentrating on two small areas to indicate what's happening to trigger our response. And in this case, if we're actually able to monitor those two areas at once, in this case with an observation post on the top of a hill, we've boiled down an awful lot of complexity into a single point of focus. But anyway, one final point before we get back to discussing the loop. Okay, so obviously all of that is an extremely simplified example. Like the quote says at the top of the page, we can't cover every possible eventuality. So that's why we use our judgment to deploy our resources as effectively as we can. However, in coming up with the plan, we'll almost certainly have to consider all sorts of other possibilities. There's actually huge value in doing that too. Because what if something unexpected happens? Well, chances are we've given at least some thought to something similar, so we're not going to be starting from scratch in decision making. And ultimately, that gives us more flexibility in our responses rather than rigidly following a plan that doesn't necessarily suit our situation. Okay, so what does all that mean for technology teams? I guess if you're involved in an active cyber defense role, maybe you take a lot of that literally. For the rest of us, though, it actually goes to the very nature of DevOps-focused teams. Having the full life cycle of a system being the responsibility of a single multidisciplinary team actually means that planning is far more inclusive and comprehensive, and we don't lose the experiences gained in that planning process. As opposed to the situations, that you may have come across in the past, where developers chuck something over the fence to infrastructure and we kind of let them worry about how to run it. But what kind of things might we want to measure? So there are resources out there that can help. The Center for Internet Security have a security metrics paper that if you're interested in things from a security point of view, that's a great place to start. But ultimately, we generally have to fall back on the consultant's answer of, well, it depends. If we're looking at things from an infrastructure point of view, maybe we start looking at resource use in our servers, memory, CPU, and all that good stuff. However, as was mentioned in the previous slide about understanding your environment, what if we're already using the auto-scaling features of our cloud provider? Maybe we rely on that and we can focus our attentions elsewhere. We're running serverless, well, there's a whole other set of possibilities to think about. To take a real-world example, though, how about a Kafka cluster we built for a proof of concept at a large UK retailer a couple of years ago? Okay, so the original idea behind this one was to use Kafka to service all of the organization's point-of-sale machines. First phase of which was to deliver pricing information down to each till. And later we were going to look at having it capture events coming back up to. So details of what's been sold for how much and that kind of thing. So obviously that kind of setup is going to get mission critical pretty quickly. So we ended up looking how we could survive an entire AWS region going down. Not sure that's ever happened, but there's always a first time. So in this case, we actually spread our cluster across London, Paris, and Frankfurt. Because if you can, why not, eh? As anybody who's done anything with Kafka will know, there's dozens of things you can monitor. So where did we start? Well, one of the go-tos for Kafka monitoring is actually consumer lag. So that's how far behind your clients are in consuming messages off your topics. But actually, in our proof of concept use case, that distributing the pricing information, we kind of didn't care. We only needed the tills to have the most recent message, and we're actually using compaction on the topics to make sure that that was the only thing that was going to be available to them anyway. So we were far more interested in the actual availability and resilience of the data, and primarily that it was being appropriately replicated. So that was the first thing we measured. We were able to make use of the existing app dynamics service they had running on each of the machines to do that. Again, at the other end of the architecture, we've got the actual tills themselves. It's a real varied bunch of devices, some old, some new. But the limiting factor that we found was memory. Nothing had more than a gig. A lot had a lot less. There was already a lot of software running on them too, so that just reduced that sort of headroom further. Actually got to the point that if we just sent the pricing details in a single file, they probably weren't going to be able to open it and read it into memory. So as well as having to rework how we sent the data, we also wanted to monitor memory usage on the tills. It was a little bit more tricky to do that, but we did manage to have that information sent up on a regular basis to a central Splunk service, and we used that for alerting. Okay, and the final thing we looked at here, and this wasn't something really considered at the start, was bandwidth. You'll see on the diagram that there's two distinct areas of the network highlighted. So there's the backbone, which was a big fat multi-gigabit pipe, and then the last mile down to the stores themselves, which was anything, again, from 100 meg link right down to cellular for some of the more remote stores. What we actually saw when we enabled things for the first time on the tills, just using the default configuration, if the tills were just polling, nothing to download, that last mile was actually fine. We're actually using a sort of measurable amount of the backbone. It was more than 10% of the backbone was being consumed just from the poll. When there were messages to download, though, that situation actually kind of flipped around, and we actually we found we were actually saturating some of those last mile links, which was a pretty bad thing, as this wasn't the only thing they were being used for, and it was only a proof of concept at the time. So there, our final monitoring was put in place with the organization's network partners, and that was to measure the Kafka-related traffic across the estate. The thing to bear in mind with all of this is that you're not going to get things perfectly correct the first time round. But as we'll see, this isn't a one-time thing. We should absolutely be prepared to both add and take things away. And again, another good example of that is on our, on our build monitors that we see in our CI environments. So I'm pretty sure everybody's seen a screen like this before. At a glance, I can see everything that's going on with all of my builds, which is great, right? It's definitely interesting, but is it actually useful? Put it this way, what actions am I going to take in relation to all of those green builds? Well, nothing, presumably, because they're all good. So what if we actually treat those like the hills in our military example and get rid of them? Okay, so now we just see the builds that are broken or in the process of being built. And yes, I do appreciate this is a different build monitor and different jobs, but exactly, just an example for now. But what I have here now is just the things I need to take action on, the failed builds, or things that I might need to take action on in the near future. I've basically taken all the noise away and left myself with just the signal. So for anybody that's interested, this is actually an open source tool called Nevergreen. It's a really straightforward thing to set up and runs in a browser, so it's definitely recommended if you want to play around with that. But anyway, now that we've got to the point where we know what we're observing in an environment, what comes next? Okay, so once something happens, the first thing we need to do is figure out what's happened and why. So in other words, we're actually just going to apply context to the observation we've gained to gain an understanding of where we are now. If the event's something we've planned for, then we've got a bit of a head start. Although we do still need to check any assumptions we've made. But in any case, there's a couple of questions we can ask to help ourselves build a better understanding of what's going on. The first of those is why. And we've probably all come across the 5 whys, where we ask the question over and over to help establish a root cause. Something along the lines of, well, people are complaining they're unable to log onto our system. Well, why? Well, the authorization endpoint looks like it's timing out a lot. Okay, why? Well, some of the database queries are taking a long time. Again, why? Well, one of the nodes has failed and the remaining ones are now overloaded. And so on. That's a really useful tool to use here. There's actually a second question that can add value here as well. And that's asking, so what? So what gives a slightly different focus. So rather than diving down and looking for a cause and therefore a solution, so what actually speaks to consequences. So if in the previous example, we were talking about a major e-commerce site and users not being able to log on meant sales couldn't be made, maybe that's a big problem. But if we're looking at some kind of less important support system, user input isn't time critical, well, maybe we take a slightly different approach to that kind of resolution. In all of that, team dynamics also plays a big part. Generally very easy to get sucked into conformity and groupthink when we're all working closely together. This is where diversity of thought and experience, plus an openness to questioning and challenge, will actually lead to a better and more complete understanding of a situation. So a good example of that is in what lawyers call facts not in evidence. So think of cases where somebody said, oh, well, we know the system behaves that way because of reason X. Well, unless the observations you put in place prove that reason X is actually true, and it's not just an assumption you're making, then that's something you should really be challenging. Because otherwise, anything you subsequently do is not necessarily going to be based on the situation as it actually is. Anyway, once we've got a handle on what we, on where we are and why, we can move on to the next phase. So in some ways, the decision phase can actually be really quick to navigate. So we've got a solid handle on the situation and a good idea from planning on how we're going to resolve it. Maybe we can fly straight through. Often, however, this is kind of where the loop can start to break down somewhat. So more often than not, probably, and despite the best efforts, we're going to have an incomplete understanding of a situation, and maybe we're missing information we'd like to have. And this is where people start to revert to analysis paralysis, trying to dig out that last one extra nugget of data from our log files, or maybe falling into speculation about what might be going on. So again, we can go back to the why and so what questions, consider the causes and consequences of the action we're thinking of taking. We probably shouldn't just limit ourselves to the immediate effects either. We need to think about whether there'll be any knock-on consequences downstream too. So we actually need to make our decision with our eyes open and take those second and third order effects into account as well. So all of that is definitely easier said than done. We do need to push through though and make a decision. So whilst doing nothing is always an option, and possibly one that doesn't get taken enough, chances are we're probably going to have to do something. And ultimately that just needs to be the best one we can do given our current understanding. So we all know the prime directive for retrospectives, that everybody did the best job they could, given the skills and resources available and the situation at hand. Well, this is actually the point we actually have to live up to that ideal. And hey, at the end of the day, maybe the decision you come to is simple and it's an elegant solution you have. Or maybe it's just the least worst option available. So I can certainly relate to the latter from my current project as well. So we had a situation where we basically hit both the horizontal and vertical scaling capabilities of a piece of third-party software we were using. And we basically didn't have any bigger machines that we could put the stuff on. The way the clustering worked meant we'd actually hit diminishing returns from having more instances. But our traffic on our platform was sort of ever increasing, and we were seeing more and more frequent garbage collections, and ultimately the instances were just entirely running out of memory, which in turn led to the other instances becoming overloaded and a cascading failure, which was generally pretty bad for our platform. So the only real solution we had was to replace it with something else. That obviously wasn't going to be a trivial undertaking, and in the end it ended up taking the best part of a year to do that. But obviously we had to keep things going in the meantime. And the only thing we could really do was schedule more and more frequent control shutdowns of the legacy app at quiet times, just to make sure that it didn't collapse in a heap during a peak of traffic. All of which is a pretty dirty way of running a system, but it works. So, I guess all of that is just really a long way of saying that as long as the decision is the right one at the time, given the circumstances, there's not a lot more that you can do. And after all, this is a loop, so you'll probably get a chance to revisit things later anyway. But before we move on to the next phase, there is actually one piece of advice that Army officers are given that may be relevant here. It's particularly the case if you're involved in a high-pressure environment or you're in the middle of a serious incident, and that's to take a Hamlet moment. Not in relation to the Shakespeare play, but actually an idea taken from the adverts for the cigar brand. It basically goes along the lines of that, even when everything's going crazy around you, you can always just take a step back, take a puff on your metaphorical cigar, and then come to the decision. I mean, I guess you could indulge in the actual cigar, but I'm not too sure your colleagues would thank you for that. But anyway, on to ACT. Okay, so ACT is probably the easiest part of the loop to talk about, whilst at the same time probably the most difficult and time-consuming to actually do. Again, maybe we're lucky and what we've decided to do is trivial, or maybe we don't need to do anything at all. But invariably, we're going to find ourselves in situations that probably require some kind of complex response. Maybe even collaboration with other teams. Again, all situations are going to be unique to your given environment. So the advice here is basically just to be deliberate about what you're doing and make sure any reasoning is well understood, it's clear, and it's communicated with everybody that's involved in the action. So finally, as we put our plan into action, we do need to be aware of what effects we're expecting to see as we transition back into the observe phase. So what are we expecting to see? How long will it take to manifest itself? Ultimately, how will we know what we've done has succeeded? Okay, so that's been a very quick overview of the loop, of the OODA loop. I hope you found it interesting. To me, it's got one of those properties that we really like when we're talking about the solutions that we build, and that's elegance. But it also belies a huge amount of depth as you think about it to its logical consequences. We could probably spend all this time again diving into each phase individually and looking at the detail you can get into there. But it's also one of those things that once you've had it explained, you probably start seeing applications of it everywhere. So I've actually got a couple of examples of that on the next slide, but for now, let's just summarize what we've just been over. Okay, so first of all, ownership. Teams need to have responsibility and authority. That is generally within guardrails, of course, but they do need to be able to build and run their own systems. So, as we saw when we were talking about the planning, the knowledge and experience gained actually early on in a system's life cycle will actually translate into a better understanding of issues when they arise, leading to better decisions being made in the resolution. So you're not having to figure out why things are going on later on. Okay, next up is maintaining a sensible signal-to-noise ratio. So tech systems are somewhat different to the military example I used earlier, as we're able to capture huge amounts of data really quickly and really cheaply. But we do need to focus on what's important and not be distracted by everything else that's going on around it. I'm sure most of us have been in those situations where you're trawling through an enormous log file, trying to figure out what's going on in a system. But we do need to be deliberate about what we instrument, and we probably shouldn't be afraid to take things out as well if they're not adding value. Okay, the next one is to always base your decisions on truth and not supposition. It's always easy to let assumptions creep into a process, but we do need to resist that and be as data-driven as we possibly can. It's not always going to be possible. There's always going to be times when you're working with incomplete information. But we do need to be driven by what we know about a situation and not what we think. So I recently saw a presentation about how AWS do postmortems after incidents. Basically, everything that goes into that postmortem has to be supported by data, and they have graphs all over. They love their graphs. But it's actually one of the signals that if they're unable to do that fully, then there's an indication that you're actually missing something as part of your monitoring process. And that's always something they take forward as an action to resolve later. Okay, and finally, we want to automate. The whole concept behind the loop It's being able to navigate it more and more quickly in order to be more agile in what we're doing. Quickest way to do that in software, have the machine do it for you. Again, maybe that's making use of some of the existing functionality that's available. Serverless is a great example here. Maybe it's something you have to put in place yourself. Either way, you should be knocking off those areas that are amenable to automation, and that then lets your people concentrate on the things that actually require human intervention. Okay, so just before I finish, a couple of links, references for you. So on the left there's some more detail about the OODA Loop itself and Colonel Boyd. His original academic paper, Creation and Destruction, is there, plus an interview with his biographer. On the right-hand side there, we've got some more tech-related stuff. So the CIS security metrics I mentioned, there's a link there. There's also a book by Jeff Sutherland, which looks at application of the OODA Loop in relation to Scrum. And if you want to see more video, more presentations on this stuff, then we've got a couple more talks. So the first one is Crossing the River by Feeling the Stones by Simon Wardley. That was his keynote at KubeCon in 2018. For anybody not familiar with Wardley maps, that actually speaks to technology maturity and strategy planning. And finally there, presentation from DevSecCon in 2018 by Nick Drake, Lessons from the Legion. That's looking at application of the OODA Loop from a kind of cybersecurity perspective. And that's definitely one you want to watch if you like your presentations with clips of big tackles from American football. But maybe not if you're not a fan of the Seahawks. He's a big Seahawks fan. Okay, so thank you for taking the time to listen. Hope it's been worth the time you've invested, and we'll give you some things to talk about when you get back to your projects. Obviously, in the spirit of the feedback loop we've been discussing, I'd be really interested in hearing your thoughts, good or bad, in the talk. So there's my contact details there. It's actually the first time I've given this talk publicly, so I'm sure there's going to be a ton of stuff that could be improved. So yeah, feel free to let me know on those details. So once again, thank you for your time, and I'll now pass you back to John, who will take us on to the next phase of the talk.
Brilliant, thanks, Chris. That's excellent. I really like and I was just googling it. The Nevergreen that you mentioned. So we might pop a link. Actually, while I'm organising the next bit, if you want to maybe pop a link in the chat for people.
I will see what I can do.
That'd be cool. Okay, so the next thing that we're going to do is we are going to have a go at running a Fishbowl, and we've got 4 people already lined up to join the. Actually, if you want to stop sharing your screen, Chris, then that'd be good. And then we should be able to see the panelists more fully in a gallery view. Great, so I'm going to invite a few people up that have put their hands up to join the Fishbowl. So we've got Neil Millard, and actually if you want to put your hands up, Neil, Ali, and George, if you want to just put your hands up, it'll make it easier for me to find you. Thank you. I'm going to promote Neil to a panelist, and we'll put George up, and then Ali. Okay, great. And are you all able to turn your videos on, or am I going to have to? Is that a setting I still need to enable? Allow participants. Good. Yeah. Okay, great. And allow participants to start video. If you can start your video, that'd be super. Oh, I've asked. Sorry, Aaron. I've put the wrong person in. I'm going to take you back to an attendee. Apologies, Aaron. And I'm going to bring Ali in and promote to panelist. Okay, great. And Chris has just posted the link to Nevergreen.io. Okay, great. So with a Fishbowl, what we do is first thing is we'll have a topic to discuss. The topic is, and Ali, if you're able to show your video, that's great. Super, thank you. So the topic is should we still be calling people DevOps engineers? And we've got our initial panelists for the set of panelists for the Fishbowl. What we do is we have 4 people on the panel at a time, and the panel is open to anybody. So if you want to join the panel, you raise your hand. There's a little raise hand button on Zoom, and then what I'll do is I'll bring you in to the panel, and then one of the panelists will have to leave, but you can't. And then as a panelist, you can't leave until someone else wants to join. And then the last thing is we talk, and when we talk, it's one person at a time. So normally we have a little rugby ball that we pass between people. It's like holding the conch. You can talk when you've got the conch. So that's what we're gonna try. We also, for running these sessions, we also have a scribe, and we have got Duncan Cheshire has volunteered to be the scribe, so I will just promote Duncan, and he'll be capturing notes as on Miro, and then we'll share the information afterwards and give us a quick roundup. So we have got 20 minutes. It'll be about 15 minutes because they'll give Duncan a few minutes to share, to do a replay. So we'll do it nice and it'll be nice and quick. But if one of the panelists wants to get us started, saying on the question of, and take a position of, should we still be calling people DevOps engineers?
Well, I guess I can start if people don't mind. So I think this one is interesting because it's very personal to me, because my current title is still DevOps engineer. It's something I've been thinking about. I didn't take any particular action on it. But I think typically when people refer to DevOps engineers, they think that there's sort of more like infrastructure developers or maybe infrastructure architects. There's obviously another side of the DevOps engineers, in quotes, that probably deal with political corporate culture. So they tackle more, meetings with CEOs and CTOs and team leads to figure out what the bottlenecks are, what's blocking the flow, right? So in my opinion, I think that I would love to have a name change, because DevOps should be sort of a culture thing, and everyone in a team that is practicing DevOps is a DevOps engineer in theory. But I get the point that as for advertisement of the role itself, it could be useful. But still, I'm in a mix of feelings there. I think that in most of situations, I'd like to be described as something else than DevOps engineer. I don't know who else has opinion on this.
Yeah, I'll pick up the reins. Sorry. So I quite like the idea of being called a DevOps engineer. Again, I'm in a role where that's labeled, but also in the role I get labeled as developer, and I feel that that's not quite adequate enough because it involves so much more. But the label still doesn't count to what it actually means. It means too many things to too many people. I mean, if you're speaking to a recruiter, it's got a very definitive sort of definition. It means you can do anything, apparently, for whatever the customer wants. But within these circles, perhaps it's got a slightly different definition. So, I agree it's still not quite right, but I don't have a better answer.
I've just promoted Stuart able to join the panelists. He put his hand up. Could one of the other people drop out, please? Well taken. The chance to leave the hot seat. Chris, you were going to say something.
Yeah, I'll jump in there. So I generally agree with what's been said so far, but it's one of those things that in some ways it kind of doesn't matter, but at the same time it really does. So I mean, what we really care about is the job that's being done behind that title. So does it matter what I'm being called? Maybe not. But I think the actual term itself is kind of losing currency a little bit. I think it's going the same way that agile has gone. That like as was said before, it has different meanings to different people, and and there's no sort of common understanding of it anymore. So maybe it's becoming less and less helpful as we go on. So I mean, I've certainly been in places where DevOps, they basically took all the people that did infrastructure beforehand, then call them DevOps engineers and say, okay, we're done now. But at the same time, I've worked on other teams, multidisciplinary teams, where it maybe fit a bit better. So ultimately, I could see it either way. Maybe it doesn't matter, but maybe we should just concentrate on the actual role that's being done underneath it all. Are we doing the right things as a team without worrying about labels that people have had attached to them?
I'm just going to bring promote Rob in. So if someone wants to drop out, and George, you've managed to jump back in. How did you do that? I didn't promote you.
Apparently it was, yeah, never mind.
So I really like so this is Ali jumping in. I think some of the points have been made are quite solid. I think ultimately the interesting thing is people need a label to refer to the work done. Just language is sort of constrained in that way, right? People need a moniker of some sort. And I think if it's a question of like the most accurate variant, I think it might be good for people who are practitioners to sort of try and come up with something. I struggle a little bit with the use of the word engineer as well, mainly because, we don't have to sign up to any sort of professional standards body or whatever. But yeah, that's my point of view.
So this idea that's beginning to emerge that almost the context matters. It's a very overloaded term, akin to kind of the architect title. I think this goes wider than just should we still refer to DevOps engineers. I think in some situations that I've experienced, actually being referred to by a title, whether that be back-end developer or technical architect, has connotations to the way that you're seen within an organization and where your role fits in, and this idea that a role is very constrained to one person. There are roles that need to be undertaken on a team. So back to the what is DevOps, something I'm seeing is sometimes you've got something that I would consider DevOps going on within a development team that has no DevOps engineers in it. And what I mean by that is kind of a team system. It goes to what I was saying about having ownership of a system. But the organization is still creating DevOps teams, which are the new ops teams, essentially. And they've just put dev in front of the words. And that then creates some tension of well, what are these teams doing? Where do responsibilities lie? So almost in trying to break down those boundaries of, well, let people play to their skills and do the best job for the organization. Actually, you need some guidance, but it flexes depending on the context of the organization, the teams, the experience of people on those teams as well.
Cool, Rob. You're the last person to join. You're muted. Sorry. Do you want to? Yeah, you just unmute yourself.
Yeah. So I think for me, the word engineer I'm uncomfortable with anyway, because I've always dealt with software developers, and developer, to me, you're developing something. Engineer feels a little bit too constructive. And I've never felt when leading teams, managing teams, call it what you will, that anything we've done has actually been constructive into a plan. It's always been borderline reactionary. So engineer just feels a little bit too formal. When you then add the phrase DevOps on engineer on top of it, beginning of this year, I was trying to work out what the difference is, and all I could find was 10% in pay, and that was it. When you looked at a current engineer or a current developer, DevOps engineer, there was literally no difference in terms of the job description, and this was from various series of companies that were out there. So I think, to me, it's almost confusing to organizations. I think to, smaller companies or startups, it's easier to take that sort of title to bring things online quite quickly and stuff like that, job titles included and capabilities. But larger organizations, to me, it's a worry that, they don't think about what is the difference between what a developer does and an engineer does, or a DevOps engineer does to a normal engineer, particularly when the circles who I work with, your large outsourcers and stuff like that, having a conversation with one only a couple of months ago, they basically said to me, oh, we're changing all the developers' names to engineers and DevOps engineers. I said, well, are they qualified? Do they do it? No, it's just been agreed, we're going to do it. So to me, I think there is a danger by operating in that way of just sort of saying it's a title. I think there's a lot that we need to do as organizations and companies to actually put a bit more standardization in there. And to the point, I can't remember the guy's name who was presenting previously, is that in development, software development, we don't actually have to be qualified. It's like an architect, unless you're part of the Royal Institute of Architects, you can't really call yourself an architect, and yet we do. To be a senior developer, what do you need? Well, 10 years worth of experience. You don't necessarily need any qualifications in it. So I think we have to be quite careful on how we describe particular roles. And to me, DevOps in itself, it's very similar. It is agile in a way, in that it is not, there's no real prescribed way of doing it, but it is about the formalization of both development and support working together to do what they need to do, which is support the business and support the customer. So personally, it's a pet hate for me. I think if there was a bit more structure and consistency across the industry, then it would be a good thing. But because there isn't, I always get quite concerned about it. Whereas maybe it's just a comfort blanket thing that I just like the word developer, because that's what you're doing. You're developing, you're creating something. You are creating something from scratch. Whereas engineering to me is more prescribed, and you're having to follow a set way of doing stuff. And I'll shush now.
Excellent, good entrance. Right, sorry, anyone would want to take that up?
I was just going to say, with the term engineer, I think there is creativity in engineering, and it's not just about following a plan. But at the same time, with this whole idea of naming and names, do you guys feel it kind of comes to a similar sort of argument around describing developers by what language they primarily develop in, which could swing round to engineer being a better title, or developer just being a better title than Java developer or Scala developer or DevOps engineer? Because it seems to me like it's just the same thing about what technologies are you actually working with.
I think the challenge with the term DevOps engineer is it sort of really seems to centralize the responsibility for following an approach or a philosophy into one or two or n people within a team. And so to me, it's actually a prototype for saying, these are the infra guys, we don't get our hands dirty. And that's just an unfortunate backsliding into a world that we've come from that we didn't like, and now we do know better.
And so we've got. Sorry, I just realised I've been a bit trigger happy, and we've ended up with 3 panelists. But so essentially that I'll leave Duncan for the replay. But in the next, we've got 5 minutes left before Duncan does the replay of that discussion. Well, actually, before I go on to that, so someone mentioned about DevOps joining DevOps. I mean, wasn't it supposed to be a culture more than any kind of job function?
Yeah, that's it. And I think it's been hijacked as a job function, like so many things do.
Okay, great. Gavin, you managed to pop in. How did you? Hello. You wanted to?
I have no idea. Here I was in a wonderful Mediterranean town, having a glass of wine. I think, given I've got a chance to speak, I think my point was really going to reiterate what Rob was saying. I think there's an education required. If we asked everybody on this call what a DevOps engineer was, we'd probably all provide a different definition. And whilst ever that exists, then there are always going to be DevOps engineers, because a company will ask for one, a recruitment agent will ask for one, a consultancy will supply one. And you know, when it comes to things like that, without that agreed definition across an industry, then there's always going to be edge cases, and not necessarily edge cases, significant cases where people misinterpret what that role is. And I think that, you know, it applies to architect, as people have mentioned. It applies to DevOps engineer. It applies to many different roles, even Scrum Master, even delivery manager. You know, it doesn't matter. There are so many different interpretations, and if we can't standardize those definitions, then we're always going to have to put up with different interpretations.
Yeah, but I mean, there's a general thing there, isn't there, with a title inflation, which seems to happen in organisations. So it's it's like it's a perennial problem. If you look at SVPs and directors of this, that, and the other. I was just, Ali, would you have one more comment? Because I think we're coming close up to time, and I was going to ask Duncan for a replay in a minute.
So the one question I do have is, so what effectively, like, you know, people ultimately need to be identified as having a skill set or wanting to do something, and, you know, recruitment folk and people, hiring managers, need to sort of identify it. So what is it that should be used to refer to folks to, you know, qualify them for a particular set of skills?
And that's almost a difficult question, isn't it? And maybe that's why we get stuck in this cycle of lots of different interpretation, lots of different meanings, causes tension at times as well, without people realizing different ideas of what people should be or not should be doing or should not be doing. I kind of feel like, you know, clever people working together with a set of skills can turn the hand to almost anything. Yes, you need people that have got expertise in specific technologies, but you need a blend of people with specific technology skill sets and people that kind of apply ideas across different technologies as well. So going to the tools doesn't, and this seems to be what it is to me, is naming people after the tools that they use. As for how should we find people's skills? I have no idea.
Yeah, I mean, that's where it comes down to seeing. Can you see people's work online? Can you see the open source things they do? That's sort of that's the ideal, isn't it? And working with them to see their skills, because all of these are so hands on, and you end up with these other assessments where it's just the syntax. So I remember doing my Java 1.4 developer exam or something a while ago, and basically learning the syntax of Java, but not that I knew how to actually write good Java at the time. So we are going to, I think, pause it there, and we're going to turn to Duncan to say how did it go capturing all of the discussion, and could you do a replay for us, and would you be able to share your screen as part of that?
I'll just have a go at sharing my screen. Let's look. Right, hopefully you can see a Miro board that I've been merrily tapping away on. Is that visible?
Yep, brilliant, thank you.
That's good. So yeah, so while you guys have been chatting away, just making some notes on a Miro board. If you guys have not used Miro before, it's a really useful whiteboard tool for, especially in the current circumstances, if you've got distributed teams and you all want to get on one board and share some ideas and pictures and things. Lots of little bolt-ons and add-ons they can use. So it's great tool. We're finding it very useful for some of the work we're doing. So I've just gone to their, picked out their mind map tool. I noticed John's in there already. He's flicking around because I gave him the link earlier, so he could be editing this at the same time. I could have, gone and made a cup of tea and he could have done this for me. But anyway, so we start with the question in the middle: should we be calling people DevOps engineers? And the conversation started off. Well, we are sort of like infrastructure architects, but should we really be called something else? Preferably not developer and not engineer. But then again, other conversation coming then. But then again, we are developing things, so the word developer should be in there. As an engineer, we are dealing with other software developers, so having the word developer in the name could be a good thing. You could delve down a little bit deeper onto that. Actually, does it matter about the technologies? Like developers get called Java developers. That's always going to be a moving target because technology always moves on. Slightly different thread. We have some that more of well, does it actually matter? It's about getting the job done. Should be concentrating on the role and not the label. But however, the name does have spelling could be a bad thing here. That's my bad. It has connotations about how we are perceived by the organisation. And there's also a danger that the name could be misleading to the actual role that we're doing. Point was brought up about there's lots of education perhaps required amongst the other stakeholders in the industry, other devs, devs, whatever, can't type, architects, the recruitment industry, scrum masters. Everyone needs to take consideration about what the role is rather than about what's actually called. But then again, towards the end, as a unit, the people need to be identified as having a specific skill set. So perhaps a label is a good thing. I think the conclusion is we didn't come to conclusion. Perhaps we needed to use the Miro board with everybody sharing on there, and then you can use the voting apps and things like that.
That's a great idea for a further iteration. I think there was one thing, it was interesting in your notes, that went further and we had more information there, which was like people need a label to hang on to identify skills. I think that's one of the nuances and challenges there. But that's great thinking. So in terms of how we might capture this in the future, maybe we do like a more a collaborative session with people on Miro. So I'll close it there, because what we're trying to do is keep these normally expert talks when we run them in person. It's in the evening. There's food. There's some drinks, and it goes on for hours. But in this kind of remote first environment, we're keeping these short to the hour, so people can get back to their families and what they're going to be doing. So I just want to say thank you very much for everybody. Thank you to Chris for the talk, and thank you to everybody who took part in our Fishbowl experiment. I think there's a few lessons for us to learn from that, but we don't learn unless we try. So thank you very much. And we are running these every week now. It'll be every Wednesday. It'll be 6 p.m. So look out for the updates on Meetup or on our website, and we'll send out the video to you all afterwards. So thanks very much for coming, everybody. I'll see you next time.